Alright, in this video I'm going to finish up our discussion of more on functions in section 2.2. It says here, putting it all together, reading a graph of a function. So here, first of all, we need to find the domain and range. So for the domain, we go from left to right. Notice we have no leftmost point here. This thing goes forever left. And we're hitting everything as we go to the right here. And then it goes forever right. And so we're going to hit every x value on this graph. There is no left or rightmost point, and we don't skip any, we don't have any gaps or anything like that. So the domain here is going to be all real numbers, negative infinity to infinity. Our range, so now we're going from the lowest point to the highest point. Well, notice we do have a highest point. It does go down forever, so there is no lowest point. Now we're looking at y values here. So y goes from negative infinity to 6. Notice that point right there is on the graph, negative 1, 6 there. So our highest y value is 6, so that's part of our domain. That's why we use a bracket here. Let me go ahead and get this shading out. Whoops. Let's see. Sorry about this. Give me a second. There we go. Alright, so we've got now x and y intercepts to look for. So notice these 2 points here. These would be your x-intercepts. That's where our graph f crosses the x-axis, so that would be the points negative 4, 0, and 2, 0. There's one y-intercept here, and that's at 0, 4. Number 3, it says find the intervals on which f is increasing, decreasing, or constant. So going from left to right, notice first we're increasing, and this is happening when x goes from negative infinity until x is equal to negative 1. So over this interval of x values, the function's increasing. So increasing on the interval from negative infinity to negative 1. And then now we're decreasing until we get to where x is equal to 4. So when x goes from negative 1 to 4, that's where we're decreasing. And notice now the function's going to be constant. And then again, that starts when x is 4, and it's going to be that way from now on. So from 4 to infinity, we're constant. At the bottom here it says find any relative minima or maxima. Notice we have a maximum value right there at that point, and we know that the maximum is the y value of that point. So we have a relative maximum of 6 when x equals negative 1. And by the way, this is an absolute maximum as well, right? Because there is no higher point on our graph. F of 0, that's just, first of all, 0 is an x value or an input. So when x is 0, the height of the graph, that would be that point right there. When x is 0, we're up 4. F of 0 equals 4. Another way to say that is the point 0, 4 is on the graph. So remember, it's input, output, whether you're talking about the point or the function notation here. So f of 0 must be 4 there. The values of x for which f of x equals 3. So f of x is another name for y. So we're looking for the points on this graph that have a y value of 3, or their height is 3. So you could draw a horizontal line at 3, so all the points on that horizontal line have a y value of 3 or a height of 3. And notice there's 2 points on the graph where this occurs, when x is negative 2.5 and also 0.5 or half. Alright, let's move on. So here we're going to talk about piecewise functions. It says a function that is defined by 2 or more equations over a specified domain. So notice if x is less than 2, we're going to use, whoops, I'm getting ahead of myself here. So if x is less than 2, we're going to use this piece. And if x is greater or equal to 2, we're going to use this piece. So let me show you what I mean by that. So in this problem here, we're finding f of 4. Notice 4 is greater or equal to 2. And so we're going to use the second piece here. So we're going to do minus our input plus 3, and our input here is 4. And so we get -1. F of -3, let's see, -3 is less than 2, and so we're going to use this piece here. So we're going to square our input and add 1. Our input is -3. -3 squared is 9. 9 plus 1 is going to give us 10. Alright, for f of 0, notice 0 is less than 2, so we're going to use the upper piece. So we're going to square our input and add 1. So our input here is 0. We're going to get 0 plus 1, which is 1. And then finally, on letter D here, by the way, you may want to go ahead and try this one if you haven't already. So if in this case 2 is greater or equal to 2, so we're going to use the lower piece. So we're going to have minus our input plus 3. So we'll plug in 2 and we're going to get 1 here. Alright, on number 2 here it says graph the function. Use the graph to find the range of the function. Alright, well, first of all, if x, let me go ahead and notice x is less than -3, we're using the upper function. If x is greater or equal to -3, we're going to use the lower function. So -3 is an important point for us. It's like it's where we go from one function to the other. So I'm going to put a line there to help us remember that. We're going to want to plug in -3 into each function to see where that point is on the graph. So if x is less than -3, we're going to basically use the graph y equals x plus 2. Remember, f of x is just another name for y. So I'm going to go ahead and make a table of values, and I'm going to pick, first of all, -3, because that's that turning point. That's where things change. So if I plug in -3 into this function, I get y equals -3 plus 2. Well, that's -1. So -3, 1. Now notice this is where things change. Notice it says if x is less than -3, we're actually at where x equals -3. So this point is not actually on the graph here, but we need it. It's like a border point for us, or an end point. And so notice I'm going to put an open circle there. But let's find a couple more points. So we need to try maybe -4. We're going to get y equals -4 plus 2, which is -2. And so that's that point. And let's try one more. If we plug in -5, -5 plus 2, we're going to get -3. And so there we go. So our line is going to look like this. So you can see it comes from the left and it goes up to that point -3, -1. But that actual end point is not on the graph, because remember, we're only using this piece of the line when x is less than -3. At -3, we're actually going to use the lower piece. So let's look at that. When x is greater or equal to -3, our graph is going to be, it'll be y equals x minus 2. So let's go ahead and do the same thing. Let's plug in -3. We're going to get -3 minus 2. Y is equal to -5. So for this piece of the graph, we start at the point -3, -5. Notice it's a solid dot because we're including that point on the graph, because we're supposed, for this piece, any number or any x value that's greater or equal to -3, we're going to use this piece. So that's why it's a solid dot. Let's go ahead and pick another number or another x value. I'm going to go ahead and pick 0 just because it's a little bit easier to work with. I can pick anything to the right of x equals -3. So let's plug in 0. We get 0 minus 2, which is -2. So that's that point. And let's plug in one more. 1's another nice number to plug into functions. We get 1 minus 2, which is -1, and that's that point right there, 1, -1. And so this piece of the graph is going to look like that. So again, if x is less than -3, our graph looks like this. So we're going to use this piece. If x is greater or equal to -3, we're going to use this piece of the graph. Alright, so we're supposed to find the range here. So we want to go from the lowest to the highest point, and we want to look at y values. So notice this thing, it doesn't have a lowest point, and it comes up to -3. I'm sorry, actually the y value there would, at this point, would be -1. But notice here we're actually at -5, and we go up. Actually, let me hit my green here. So you can see that we're hitting every y value. We're actually repeating some of them. We're going from -infinity to infinity. The values between -5 and -1 are repeated on these two lines. But we're hitting every value, so the the range is all real numbers. Alright, let's move on to the difference quotient. So for those of you going on to calculus, this is a very important concept, and we're just going to give you some practice evaluating it. It says find the difference quotient for f of x equals 2x minus 5. I'm going to do this in steps. So first of all, let's make, because we got to find this expression here. So we're going to do it in steps. So let's make a skeleton or a shell. Now the first thing I want to do is find this part here, f of x plus h. So let's plug in x plus h. So we'll distribute here, we get 2x plus 2h, and then bring down the minus 5. So this is f of x plus h. Now let's put that together and find basically the numerator here, f of x plus h minus f of x. Well, that's going to be f of x plus h, which is what we just found, minus f of x. Now be careful, we're subtracting f of x, which is a binomial. It's got two terms. You need the parentheses here. So this would be f of x plus h minus f of x. So let's go ahead and simplify here. We can drop the parentheses on the first three on that first part there, and then we have to distribute the negative there. Notice the plus 5. Now notice we have some terms that are going to cancel each other out. The 2x and the minus 2x, the minus 5 and the 5. And notice all that's left is the 2h. So finally we're ready to find the complete difference quotient. So I'm going to write that here. F of x plus h minus f of x all over h. Well, we already found the numerator. That was 2h, and our denominator is h. And so we're just going to get 2 here. Alright, let's move on to number 2. So again, let's start with the skeleton or shell. And the first thing we want to do is find f of x plus h. Now this is going to be a lot of algebra here. So the x plus h squared, be careful, that's not x squared plus h squared. You're going to have to FOIL this. You're going to have to multiply two x plus h's. So we're going to get x times x, which is x squared, x times h, which is xh. Now in the lower, or the inner product here, it's hx, but I'm going to go ahead and write it in the same order so it looks the same as the other one. So xh. and then h times h is h squared. So notice we do have two like terms here. We're going to end up with x squared plus 2xh plus h squared. So let's go ahead and put that in. It's 2 times that. And then let's go ahead and distribute here. It'll be plus 3x plus 3h and then minus 1. So all I did was distribute here and brought down the minus 1. So we need to also distribute the 2 here. Let me do that. And then bring down the rest. And in fact, you can look at that. It's awfully long, but there are no like terms, so we're done. We just found f of x plus h. So now let's do the next part, f of x plus h minus f of x. Well, we just found f of x plus h. It's all of this, so let's bring that down. Minus f of x, so it'll be minus, and notice we have 3 terms here. Again, we need to put those 3 terms in parentheses. So this is f of x plus h minus f of x. Alright, well let's drop the parentheses on the first one there. We don't need those. It's just a one of those, and so we don't need that. And then we need to distribute the negative for the last 3 terms there. So minus 2x squared minus 3x plus 1. Now let's look for our common terms here. We have a 2x squared, I should say our like terms, and a minus 2x squared, so those cancel each other out. We got a 3x and a minus 3x, and notice the minus 1 and the 1. What you're going to find when you do this kind of problem is all of these terms from f of x end up canceling out. It's a nice thing to know and to look out for. And so what's left? We got a 4xh plus 2h squared plus 3h. Well, we're almost there. We got one more step, so we're finding the difference quotient. That's this. We just found the numerator, so let's put that in. And our denominator is h. So we know that we can simplify this by breaking it into 3 fractions. Notice on the first fraction there, the h's cancel, you get 4x. H squared over h, we're going to get just h, or 2h, because of the 2 there. The h's cancel on the last one, and you get plus 3. And that's the difference quotient for this function. And that's the end of the video.